Auzu billahi minash shaitanir rajeem. Bismillahir rahmanir rahim. So today we will discuss the another rule for electronic configuration, which is Hund's rule. In previous lecture of the part 3 we discussed the Abba principle. Now we will discuss the Hund's rule. Abba principle was actually about the distribution of electrons and the uh, subshells of an atom. Now this is the Hund rule is about the distribution of electron and inside the orbitals of an atom. For example, if we look to the uh, p orbital, that is the p subshell composed of three orbitals. One is the px, one is the py, and one is the pz. Px, Py, and Pz. So this Px means that this orbital is in the x-axis. This is dumbbell shaped in the x-axis. The Py means in the y-axis of a dumbbell shape. This is a in y-axis, so this is Py, and Pz is in the z-axis, a dumbbell shaped, so this is a pz orbital. Actually this orbital mean that the probability of electron may be here, maybe here, maybe here, so these are only the probability, these orbitals. Hunt says, come to the topic. Hunt says that if there are 3 electrons according to the p subshell, so these 3 electrons will accommodate and separate px, py, and pz orbital respectively, and parallel spin. Parallel spin mean if the first electron is in a minus half spin, these spin, we will discuss these spins and the Pauli exclusion principle in the upcoming lecture. One electron is in the plus half spin, and one spin of the electron is the plus half spin. One rotate with the clockwise and one rotate with the anti-clockwise, and that orbital around its own axis. So this is called the spin of electron. One is the revolution of electron and one is the spin of electron. Revolution of electron is in the revolution of an electron around the nucleus, and spin of electron mean the spinning of electron around its own axis. So minus half spin and plus half spin will be then discussed in the next electronic configuration lecture, which will be based on Pauli exclusion principle. So this is px, py, and pz. These 3 electrons are an parallel spin. If we look to against the Hund rule, if we place these electrons as like this, and one here and the anti-parallel spin, so this electronic configuration is unstable, and the first one is stable. That is why Hund says that all electron will be placed in the parallel spin if 3 available. If the fourth electron comes, for example, suppose, then it will be placed in the px orbital and an anti-parallel spin to minimize or to cancel the spin of the other electron. So one will be here in the plus half spin and another will be here in the negative half spin. So if we look to this, for example, take the first example that all electrons are in parallel spins. This is the most stable electronic configuration because the periodicity of properties are stable here. If we look, for example, if we look to this configuration, the ionization potential of this will be high. The electron will not remove easily from this atom or from this orbital. So the Hund rule also tells about most of the stabilities and most of the stable electronic configuration. So this was all about the electronic configuration by Hund's rule, and we take example of the p orbital.